All right, so now we're going to talk about how we take these how we perform scalar multiplication. And we probably already saw this, but it's good to, just go over it since we're going to contrast it with the other forms of multiplication we have coming up. So remember we have a scalar, we'll call it A in this case, and we have a vector, we'll call it X, Y, Z. So this would be a three-dimensional vector. And to do scalar multiplication, we just distribute that A to each term. So we're going to end up with the vector AX, AY, AZ. If we wanted to do that, let's do a couple examples. So for example, we could try something like what is the product between the scalar 3 and the vector 2, -1? Well, that would just be 3 times 2, comma, 3 times -1, which is just going to be 6, -3. So nothing terribly crazy there. Just as a slightly longer example, what if we did 4 times, we'll say 1, 0, -1, 6. We'll just multiply each element of our vector by 4, so that will give us 4, 0, -4, 24. And it's worth noting that we can also divide. So like let's say we were looking at the vector 2, 8. We wanted to divide it by 2. Well, that's just the same as multiplying by 1/2. So that would just be 1/2 times the vector 2, 8, which would give us 1, 4. For the last example we'll do, I want to first remind us of a fact, which is that we can take a vector in R2 or R3 and represent it as a linear combination of standard basis vectors. That sounds complicated. What that means is that if we want to talk about the vector 1, 2, we can write that as 1i plus 2j. The standard basis vectors, so I is just a shortcut for writing the vector 1, 0. J is just a shortcut for 0, 1. So when we do the multiplication and we add these together, we see that this ends up being the same thing. If we have a two-dimensional vector, those are going to be our standard basis, I and j. So just as another example, 3, 5 would be 3i plus 5j. And maybe as a slightly more interesting example, if we had 0, -1, that would just be -j. We also can have three-dimensional vectors. Then we'll use I, j, and k instead. So like 2, 0, 1 would equal 2i plus 0j plus 1k, which we would normally just write as 2i plus k. So with that in mind, we can do our multiplication here. So let's actually use that last example. If we wanted to do, how about -5 times the vector 2, 0, 1, oh, not going to write it like that. If I take -5 times the vector 2i plus k, then this is going to look exactly like normal distribution. That's going to end up being -10i plus 5k, plus -5k, which we would translate back to -10. That's the first component. It goes with I. Since there's no j, that means that this is just going to be 0. And since that k is going to be our third component, that's going to be -5. So There's some examples with scalar multiplication and a little bit of a example with how we use the standard basis vector notation.